Without replacement, the second selection is the conditional probability because it depends on what the first selection is. Suppose we have an urn that contains two types of balls, green and red. There are 7 green balls and 5 red balls, so there are a total of 12 balls. If we randomly take one and if that ball is green, then the probability that we will get the green ball the second time is only 6 out of 11. If the ball that we took out was red, then the probability that we will get the green out the second time is 7, because there are still 7 left. We only took the red one out, divided by 11. And so this second selection depends on what the first selection is. Again, if the first selection is a green ball, then there are a total of 6 green balls left out of 11 balls left. We took one out already, so there are only 11 total left. And we took the green out, so there are only 6 green balls left. And if the first selection is a red ball, then there are 11 total balls left, and out of those 11, there are still 7 green balls. With the same events of getting a green ball the second time, the probabilities are not equals, are not the same, depending on what the first selection is. And so without replacement, this is again the conditional probability. And we denote this probability as the probability of getting the green ball the second time given the first selection. And so there are two cases in this scenario. The first probability is the probability of getting the green ball the second time, given that the first ball was green. And for the second, it is the probability of getting the green ball the second time, given that the first ball was red. Clearly, this is, again, the conditional probability.